In this video, we're going to solve two-step equations. And you can see we have two different problems here, two different looks, one with a fraction and then one without a fraction. We'll start with the easier of the two, which is the one without a fraction. And what you need to look at is you need to look at the different operations that are occurring in the two-step equation. So you can see that you have 2t, and because there's no sign between these and they're joined together, that is a multiplication. So I have a multiplication here, and then I have an addition here. In order to solve an equation, I have to do the opposite operations. So I have to, instead of adding, I have to do the opposite, which is subtracting. And instead of multiplying, I have to do the opposite, which is dividing. And I'll typically always start with additions or subtractions. So I'll start by subtracting 6 on both sides to make sure that both sides are still equal to each other. We want to keep the equality between the two sides, and the equal sign is saying that both sides are equal right now, so we need to subtract 6 from each side. That gives us 2t, because 6 minus 6 will cancel out, so we can cross that out. And we have 2t equals 8 minus 6 is 2. Now I have to do the opposite of multiplication, which is division. So I'll divide 2t by 2. And if I divide the left side by 2, I have to divide the right side by 2 to keep the equations equal. 2 divided by 2 is just 1. So I could either write 1t here or just t, because they mean the same thing. And then 2 divided by 2 is 1. Now this tells me that 1 is my solution, and I can always check my solution by going back and plugging into the equation. So I think this is the answer, but let's plug it back in and check it out. So I'd have 2. If I replace the t, because we now know t is 1, so I have 2 times 1 plus 6. The question is, does that equal 8? 2 times 1 is 2, plus 6. Well, yes, 2 plus 6 is 8, so I can check that off. That is my solution. Let's move on to the fraction problem here. So I have a fraction, and a fraction just means division. This sign is the division sign. So I have two operations here. I have division of 3, and I have subtraction of 2. So I need to do the opposite of each of those operations. I need to add 2, and then I also need to multiply by 3 because I'm dividing by 3 here. I'll start with the addition and subtractions. So I'll add 2 to both sides to keep them equal. So plus 2 on each side. This gives me 4 equals d over 3, because negative 2 plus 2, well, that's going to cancel out. Now I need to multiply by 3 because I have a division of 3 here. So I multiply by 3 over 1, and the reason I write it as 3 over 1 is this is a fraction, so I need to use the fraction version of 3, which is 3 over 1. And then on this side, I don't have a fraction, so I can just use the whole number version of 3. So I take that times 3 to keep them equal. You can see that this is really 3 divided by 3. I have 1 3 in the numerator, 1 3 in the denominator, so I can cross cancel. And when I cross cancel there, I end up with just d over 1, which would be just d. 3 times 4, that's 12. So I think that my solution is 12 for d. That's what we think d should have been, the missing number. Let's check it by plugging it in. When we go to check that, we get 2 equals, we replace d with 12. And I'll put parentheses around the 12 just to show that d was there. You don't really have to do that. So the question is, does this all equal 2? 12 divided by 3, that gives you 4 minus 2. Well, we know 4 minus 2 is 2, so that checks out. So that was our solution. Now we're going to keep moving on and hopefully get some more difficult problems as we work. So we have one that's really similar to the previous problem. I have division of 4 and a subtraction of 1. I need to do the opposite operation. So if I see the division of 4, I need to multiply by 4. If I see subtraction of 1, I need to add 1. So I'll add 1 to each side. I get 3 equals b over 4. Negative 1 and the positive 1 cancel. Now I need to multiply by 4 because I'm dividing by 4 here. So I multiply by 4 over 1, and I multiply this side by 4. I used 4 over 1 because b over 4 is a fraction. I can cross cancel because I have 4 in the numerator and the denominator. So that will divide out to be 1. 4 times 3 is 12 equals B. I think 12 is a solution, so I go to check it, and I'll plug it in, and I get 2 equals 12 for B over 4 minus 1. And I'm trying to see, does this right side equal the 2 there? 12 divided by 4, that's 3. So I have 2 equals 3 minus 1. Well, we know 3 minus 1 is 2, so that checks out. So 12 was the solution. Now we're going to solve this equation, which was like the first problem that we had. It's just rearranged differently than the first problem we had. We have 2 times q, so we have a multiplication here. I'm going to have to do a division of 2. And because the 8 is positive, that means that I'm going to have to subtract that 8 out. And you can see that there's an addition of 8 here. So I'm going to subtract the 8 first. And we subtract 8 from both sides. You get 12 equals 2q. And then I'm going to have to do the opposite of multiplication, which is division. So I divide by 2 on both sides. When I divide by 2 on both sides, the 2's cancel because I have 2 divided by 2, which is 1. So I can just write q instead of 1q. Either one would work, but q works the best, looks the best. 12 divided by 2 would be 6. So we think that the q should have been 6. We go through and we check it. 20 equals 8 plus 2. And I replace the q with 6. 2 times 6 is 12, so I have 20 equals 8 plus 12. Well, I know that 8 and 12 equal 20, so we can check that off. Our answer was q equals 6. So far, these have been pretty standard two-step equations. Now we're going to get some two-step equations that include a little bit larger fraction. So you can see that now, these are usually the scary ones. Now we have p minus 2 on top, so we have 2 terms on top of the fraction, and then 3 on the bottom, and then x plus 7 on top, and then 5 on the bottom. It looks scary. It's actually the same steps that we took in the previous problems. I look and I see I have a subtraction of 2. That means I'm going to have to add 2. I have a division of 3, so I have to multiply by 3. But the issue that I run into here is now I can't do the addition and subtraction first because it's on the top of the fraction. So I need to actually do this multiplication of 3 first. So it just changes the order that we have to do the operations. I'll start by multiplying by 3 over 1 because I am dividing by 3 here. If I multiply by 3 on the left side, I'll multiply by 3 on the right side. I have 3 in the numerator divided by 3 in the denominator. They can cross cancel. And that's going to leave me with p minus 2 over 1. So I have p minus 2 is equal to 9. Then I have to add, because I have a subtraction of 2. So I add 2 to each side. And I get p equals 11. So I think that that is the solution. I'm going to check it. To check it, I plug it into the original equation. That's 11 minus 2 over 3 equals 3, the original problem. 11 minus 2 gives you 9, so I have 9 over 3 equals 3. And the question is, are those equal? They are. 9 divided by 3 is 3. We check that off, so our solution is p equals 11. This problem looks different variable, different operation in the numerator. Same process. I'm dividing by 5. I have to multiply by 5. I'm adding 7. I have to subtract 7. But I cannot do the subtraction of 7 until I multiply by 5 first to cancel the fraction. So I multiply by 5 over 1 on the left side and multiply by 5 on the right side. I have to do 5 over 1 because this is a fraction. So I use the fraction version of 5. Cross cancel because there's a 5 in the numerator and a 5 in the denominator. 5 divided by 5 is 1. So I get x plus 7 is equal to 4 times 5, 20. Now I have to do the opposite operation of addition. So subtraction of 7 here on both sides. And I get x equals 13. So I think the solution is 13. I'm going to check my answer by plugging it back in. When I check it, I get 13 plus 7 over 5 equals 4. And I'm looking to see, does the left side equal 4? 13 plus 7, that's 20 over 5. Well, 20 divided by 5 is 4, so I can check that off, and this is my solution. Now, we checked each answer in these two-step equations. A lot of times you can just use your calculator to do the checking. You can take your calculator and plug in the 13 plus 7 divided by 5 and see if you end up with 4 without doing the extra writing.